Welcome to this minor series video. In this video, we are going to look at factorization. Specifically, we are going to look at the difference of two squares and how we can factorize a difference of two squares. So graphically, this is a square. We can write a square algebraically as a squared. So the difference of two squares. So graphically, as we saw before, this is a square. It has length A, which means all the sides have length A. This is another square. This one has length B, which means all the lengths of this square will be B. Now, if you find the area of the bigger square, you'll have A squared, and the area of the smaller square, that will be B squared. Now, as you can see, because the first square is bigger than the second square, there will be a difference, a gap, and that is represented by this red rectangle. Now we can write this the area of this red rectangle algebraically by saying the area of the big square minus the area of the smaller square. So this is a squared minus b squared, which is a difference of two squares. So how do you factorize a difference of two squares? So if you are given a difference of two squares, the first thing that is important is realizing that you have a difference of two squares. So a squared minus b squared. A squared is a square, b squared is a square, minus means that you are subtracting, and when you are subtracting, the answer that you get is a difference. Hence the name difference of two squares. So the way that you factorize a difference of two squares is you open two brackets, you take the square root of the first square. So the square root of a squared is a. So a times a will give you a squared. So if you were to multiply a with this a, you get a squared. And then b times b will also give you b squared. So b times b excuse me, will give you b squared. And then let's come to the signs. So firstly, you'll put positive and then you'll put negative. What is also important to note is that positive times negative, that will give you the negative that you have originally in the difference of two squares. So the signs are always important to remember. The first example, you have a squared minus 49. Now 49 is a square because 7 squared is 49. So you open two brackets. A times a will give you a squared. 7 times 7 will give you 49. And then you will have a plus and a minus. Very important, remember the signs. So this one is similar to the one that we had before. You have A and you have B plus minus the signs. Example 2, you have a squared minus 9. 9 is a square, a squared is a square. So you open two brackets. A times a will give you a squared. 3 times 3 will give you 9. Then you have a plus and a minus. Then you must remember that the signs must not be the same. Again, x times x will give you x squared. Y times y will give you y squared. Then you have a plus and a minus. The signs must not be the same. Finally, the This one is a bit interesting because you have a number as the first term, and also you have another term where you have a variable and a coefficient. So 4 is a coefficient of b squared. But b squared is a square, 4 is a square because it's 2 squared, and 16 is also a square. So you have a difference of two squares, you open two brackets, 4 times 4, that will give you 16, 2b multiplied by 2b, that will give you 4b squared. So you have a plus, you have a minus, the signs are not the same. Finally, you have another difference of 2 squared. So no matter how long the term may be, like this one, but all you need to focus on is that, is it a square? 9 is a square, y squared is a square, z squared is also a square. So x times x will give you x squared, 3yz times 3yz, that will also give you back what you had, which is 9y squared z squared. Then you have a plus and a minus. The signs will not be the same.